So hello, good afternoon everybody. I am Jeremae V Patindol and welcome to our maritime discussion. Now today there are five instructors to discuss throughout this lesson. We have Mr. Cabantoc, Mr. Labadan, I, Patindol, Pesquera, and Mr. Undalok. Now let's begin. Now the lesson objective for this discussion is cargo operation, ballast tanks, buoyancy and ship stability, structural failure, and lastly capsizing. So let's begin. What is cargo operations? Well, this refers to the operations done from port to ship or ship to port, for the cargoes being loaded, cargo going in from port to ship, and unloading, which is from ship to the port. It refers to the loading, discharging, stowing, lashing, securing, surveying, and many more activities depending on the type of ship and cargo. The person that's overall responsible for the safe loading and stowage and these operations is the master. However, the handling is delegated to the chief officer. So if you notice, if you go to the pier stations in SM or any ports rather, you can see that there are cargoes or container trucks being loaded from the ship to the port or the other way around. This is what you call cargo operations. It's from delivering the cargo from the port itself to the ship or the other way around. Next up is, did you know that we don't use the same cargo techniques or operations for every container, because each cargo has different characteristics and unique operations required to unload or load these cargoes, such as, well, for example, you cannot use the same loading technique for cargo operations if we're using other cargo such as RORO vehicle or vehicular or even dry drain. This is because each cargo or each goods are different characteristics to itself. An example would be in container ships, we use, if you can see in container, there's big cranes that lifts up these cranes in the background. As you can see, we use giant cranes to pick up the cargoes from ship to port. On the other hand, however, for chemical tankers which are liquid, we cannot use cranes because, well, they are liquid. So instead we use pumps or any other methods that is required. So these are the types of ship. We have the container ship, the reefer ship, RORO, and chemical tanker, and of course there's many more, but these are four commonly. Container ship uses crane because it's very obvious. They use crane to lift up the ship from port to ship or ship to port. Reefer, on the other hand, the reefer ships, if you do not know, are ships that contain perishable foods such as bananas, meat, or any food that require cooling. This operation is done differently because it needs a required temperature to sustain the food and prevent it from being contaminated or going stale. For RORO ships, this is primarily used for vehicular or motor transporting, and we cannot use cranes, and as you can see from the picture, we instead use ramps to discharge or load the vehicles on board the vessel. Lastly, we have chemical tanker, which transport liquid chemicals such as gas, petrol, oil, LPG, and other many liquids. Of course, we can use the same methods compared from the container or RORO ship because they are liquid, so instead we use pumps or any other methods required. Some chemical tankers as well require certain heat on it to keep the viscosity of the liquid on board safe and stable. So that would be all for my part of the cargo operations, and the next person who will handle ballast tank is Mr. Labadan. Take it away.
Thank you, Mr. Patindol. Now I am Jeremae V. Labadan. I am going to discuss you about the ballast tank. Now, what is ballast tank? A ballast tank is a section of a boat, ship, or other floating construction that is filled with water and used as ballast to reduce or control buoyancy, provide hydrostatic stability, or both. Now let's go to ballasting and deballasting operations. A ship that is not loaded or not carrying cargoes must pump sufficient water into segregated water ballast tank to ensure ship's stability, stress, draft, trim, and propeller immersion that should be within permissible limits to ensure safe navigation of the vessel at various sea and weather conditions. On the other hand, it will pump out the water at the port as the loading operation progresses to maximize the ship's cargo capacity. Now, did you know that there are various bacteria and species that can thrive on the ballast tank? The example of these species are plankton bacteria, viruses, microinvertebrates, fish eggs, and microorganisms. Efforts to mitigate the spread of invasive species through ballast water management involve the use of ballast water treatment systems. Ballast water exchange procedures and regulations aim to reducing the transfer of harmful organisms between different marine environments. And that's all. Thank you. And I'm going to pass it to my Mr. Cabantoc.
Hello everyone, I am Cabantoc, and today we're gonna tackle about buoyancy and ship stability. So, what does buoyancy mean? Buoyancy is the tendency of an object to float in a fluid. In short, it is a tendency of an object to float or to rise in a fluid submerged. This fluid can be either a liquid or a gas. The pressure of water on the boat below the waterline pushes upward, creating a buoyancy force. So, what is ship stability? Ship stability is an area of naval architecture and ship design that deals with how a ship behaves at sea, both in still water and in waves, whether intact or damaged. It has three types of state stability of a vessel, namely stability, neutral, and unstable. So first, what is stable? Stable is the ability of a ship to float in an upright position and, if inclined under action of an external force, to return to this position after an external force has ceased acting. Second is neutral. Neutral stability is a displaced inclination of an external moment remains that displaced position when the external moment is removed. The body is said to have been in neutral equilibrium and has neutral stability. Lastly, unstable. Unstable means when a ship loses its equilibrium due to an external force, for example, a gust of wind. The distribution of upward force on the hull changes. The outcome is that the resulting buoyancy will move in the direction of movement of V with an increased list.
Structural failure of a ship. This refers to any breakdown or collapse in the physical components that make up the vessel's framework. In worst case scenarios, disaster tend to happen early. In this case, structural failure happens to a vessel or a ship that you may be on board with. This can vary from erosion, hull failure, bolting, rupture, foundation failure, and many more. Examples of structural failures: erosion, hull failure, and overloading. Erosion. Imagine your ship's metal parts gradually wearing down because of constant rubbing against water, waves, and other stuff in the sea. This can happen faster if you're sailing in rough waters or area with a lot of sand or plants. Eventually, if not fixed, this can make your ship weak and prone to breaking. Hull failure. Think of the hull like the outer shell of a nut protecting what's inside. If it gets damaged from hitting something, rusting or just getting old and big, it can crack or break. Water can then leak in, which is a bad news for keeping your ship afloat. Overloading. Picture trying to carry too many heavy bags. Eventually, your arms might give out. Similarly, if a ship carries too much weight, it strains the structure. This can lead to things bending or breaking, especially if the weather gets rough. If the ship can't handle it, it might tip over or sink.
Capsizing ship or leaning over occurs when a boat or a ship is rolled on its side or further by wave action, instability, or wind force beyond the angle of positive static stability, or it's the upside down in the water. The act of recovering a vessel of a capsize is called righting. Capsize may result from broaching knockdown, loss of stability due to cargo shifting or flood, or in high-speed boats from turning too fast. So, how to prevent capsizing on ship? Balance the load of all passengers and gear. Keep your center of gravity low by not allowing people to stand up or move around while underway, especially in smaller, less stable boats. In a small boat, don't allow anyone to lean a shoulder beyond the gunwale.
That's all. Thank you.